All right, good afternoon. We're going to get started here in just a second. This, just to make sure you're in the right place, this is the TFDM Terminal Publication Service, TTP, ATD-2 style. Up here with me, I've got Eric Van Brunt. Sorry. I'll have him introduce himself in a second. I'm Sean Gorman. I'm a software architect with Mosaic ATM and the software architect on NASA ATD-2. Been with ATD-2 since the beginning, plus the precursors, and worked enough with the TFDM team to try to keep us in sync so that we're kind of working towards the same beat of the same drum here. So, Eric.
Yeah, I'm Eric Van Brunt. I'm a Leidos solution architect and the TFDM system architect, helping implement TFDM for the FAA.
All right, so if you got questions throughout, use the conference IO. Anything's fair game. Anything on how we're doing with ATD-2, I can clarify if you want specifics on how TFDM is going to handle it, timing, stuff like that. Eric will handle it. I think we've got enough time where the slides won't take up majority, so we should have a fair amount of time for some Q&A towards the end of this. Famous last words. All right. Well, technical help. There we go. We're like done now. All right. So, if you're not familiar with TTP, it is going to be the feed being published by TFDM. This is the outbound stuff. There's other feeds that are happening internally, but this is the main one that's going to give you all this great data that's going to be produced by TFDM. It's all going to be done over SWIM, just like the rest of the SWIM feeds in XML format, PubSub. This basically is data that doesn't exist in other feeds, which will, come to light in the rest of the presentation. Additional flight elements, but also your airport information, surface metering, traffic management restrictions, things that don't necessarily exist in a SWIM feed today, and coming to an airport near you. Come on, clicker. All right, so ATD-2, we implemented TTP probably 2 years ago or so now, and we've now made it available on SWIM R&D, and if you go to the NSRR for the documentation, you'll see it termed NASA TTP, and what we're doing is trying to follow the TFDM specs as close as possible, so we took their specification, their formats, and we basically backed it with the ATD-2 data, following it as close as we can. No deviations from the specs themselves, so we didn't change the elements, but there's some slides here to talk about. We can't necessarily implement everything that's in the specifications, but we implemented what we could. And the whole idea is for you guys to be able to have a kind of a prototype to get out in front of this before TFDM comes along. We're currently publishing for Charlotte and Dallas-Fort Worth and Dallas-Love Field. And these are really the only planned airports for ATD-2 on our timeline. These are basically our research airports. So while TFDM, when they come along, eventually we'll have upwards of 80-something airports, I believe. For the prototype and what we have, this is our planned list. So we will keep this going until TFDM comes along. We have things in the works. Even though ATD-2 ends in roughly a year, we have things in the works to keep support of the ATD-2 system going until TFDM comes online. So this feed will stay online until the TFDM one subsumes it. So it'll be out there for you to continue to learn and get educated and get prepared. Again, the big goal for NASA and one working with TFDM is we want to do this in a way that any time you invest in this feed is not lost when TFDM comes along. We wanted to find ways to collaborate and share the information, and I want to give credit to Al Capps, who had really pushed this way early in the ATD-2 timeline of aligning with TFDM and not doing things in a way that was just so specific. I don't know why I try to say that word because I can't ever say it, but try not to just do it a NASA or an ATD-2 way. Try to do it in a way that will live on, and so that's why we kind of went with that specification. And that way, when you spend time trying to learn how to consume that data, hopefully, all that any effort you put into it pays off and can be used when TFDM comes along. Just a quick diagram. I mean, if there's time, we'll talk a little bit at the end, just kind of some differences between the fuser and TTP. I think it's getting a little clouded. You know, TTP is a little, you know, is providing you a lot of added value that you don't have now, or the fuser is a different application of fusing things together. We'll try to clarify that some, but you know, just showing here, I mean, there is a bunch of data coming in, just as it will in TFDM, where a lot of data sources are coming in and being fused together as inputs into this system, and there's a surface system now basically generating all this new quality data that's being put out in the service over TTP. And for those that just sat in the Miner mobile app, and they are one of our use cases where they are a TTP consumer, and they're using that information for what's happening in the surface system, and then they're providing EOBTs back into the system, so a nice little collaborative sharing. And it's out there. We've got a few airlines already hooked up. We've got some other researchers hooked up to the TTP feed, trying to learn from it. And so it's out there and moving along. Clicker's awful. So why would you want to use TTP? And I mean, in a nutshell, there's just data that you just can't get anyplace else. You know, and why it doesn't go anyplace else, it just naturally doesn't fit anyplace else. I mean, TFDM, you know, as Mike presented earlier, I mean, when it's coming, it's a big program. There's a lot of money being put into it. But it's a lot of new capabilities, and it doesn't, you know, that's why there's now 3 Ts, you know. There were 2 before, and that was a 3rd one. It just naturally doesn't fit, neither does the data. You're getting surface data, you're getting just information that just isn't available in the other feeds. So if you want it, this is where you want to come to get it. So why have a NASA one? You know, I kind of hit on all that stuff earlier. I mean, that, you know, we're trying to get it out there so you can integrate with it early, get used to the data, provide feedback. And when I say provide feedback, I mean they're in their waterfall model. They're not going to be able to make adjustments, you know, next month, you know. But if you get used to it and you're not getting what you need out of it, or something's missing, at least you're getting into the pipeline earlier. So the earlier you get into it and learn how to use it, the earlier you can start getting feedback and get into, you know, whatever change request you might want for a future TFDM work package. I don't know when that would be, but again, the sooner you get to playing with it, the better. So some limitations, and you know, we're a surface system, TFDM surface system. There's a lot of complementary capabilities, but we're not doing things exactly the same, and we don't have, you know, ATD-2 was a research mission, and we kind of basically went where the research took us. TFDM has a pretty well-defined set of requirements that they're trying to hit. We don't have all those same requirements, so we don't necessarily have all the exact same data that we can publish. And while we do have additional data for other reasons that we could put in there, they don't necessarily fit into the specification. And then you got this third entity, which is FIXM, where basically that's the format for the flight data that was agreed upon. And FIXM, you know, is pretty well defined. That takes time to get changes. So, you know, the Venn diagram shows you there's a sweet spot between, you know, TFDM, ATD-2, and what you can fit in FIXM. And, you know, that's, you know, what TTP is. And it's all kind of evolving. FIXM is expanding to make room for more things, and they have expanded already. But those are some of the limitations we kind of dealt with. Kind of another thing, I mean, this is just a general comment. It's not, you know, it's not that you won't find any elements that don't overlap, but, you know, in general, the TTP feed has elements that don't exist in the other feeds, but it's not meant to be take every element that's in every feed and also put in the TTP. So there are some exceptions to things that you can find in both feeds, but you know, the edict, for example, is not currently in TTP, so you get that out of a different feed. And whereas the targeted times that are in TTP for a targeted runway time, you get that out of TTP. You won't find that in another feed. You know, the runways and predicted runways and all that, those are going to be TTP and not others. So again, not to make this about the fuser, but you know, it's still, there's still a place for the fuser where you're still bringing together data from multiple sources, and TFDM is doing that behind the scenes with their own fusion type engine. All right, so take a quick glance, see if we're getting any early questions.
One. So the question was, will data provided to TTP, such as EOBT, be validated anyway? So the EOBTs that we get through the TFM data feed, actually, we don't actually will validate them, but we do track accuracy. If we go through and start to see that the data quality of those EOBTs is far off from the actual off-block times, we'll be going back to the sources that were providing those. So, you know, that from that perspective of a data quality validation, the security validation, we're working with CDM participants in some of this data that's being provided to us. So that comes through the secure kind of CDM data provision.
And that comment's pretty well true of ATD-2 as well. I mean, we're handling it in the same way. We're constantly looking at the EOBT accuracy and trying to provide feedback to the providers. And, you know, that in general, they're as good as anything. You know, that most of them are based off of L times early on until they get their models, you know, more sophisticated. But yeah, pretty much the same. All right, as far as the TTP services themselves go, there's actually 6 services, and one being the flight data. You know, you can imagine what that is, but there's some elements that we'll highlight here, but all this stuff is pretty well documented in there, both the TTP documentation from TFDM and the ATD-2 side on what's actually in the flight data. But then it probably gets even more interesting from there when you start getting into these other services, because these really are things that you can't find these anyplace else. And it's always been, you know, I've been on a number of efforts where it'd be great to have these. We're having to derive the data ourselves. Or you basically write your own algorithms to figure these things out and mine the data. But airport configurations, airport information, what flow you're in, you know, what runways are active, you know, runway closures, all these kind of things. These will be in the data, and you know, these are going to be input from the controllers there, and that's, you know, making out. So it's as real as it gets. Similar traffic management restrictions, and really interesting about the traffic management restrictions is, you know, you compare the traffic management restrictions with the flight data and not just know what restrictions are out there, but what flights are included in that restriction. And that in itself is really difficult to come by. It's hard enough to find good sources of restriction data today, but then also happen to know what flights really got included in it. You know, you're trying to match some logic on some system that you don't necessarily have that insight into, and now you'll have that information coming out. And then they've got flight delay and operational metrics. I mean, these are basically, you know, metrics about the airport and metrics about the flights that are being produced. A lot of these things might be things that you want to compute, and you're gathering a lot of data today trying to figure these things out, and TFDM is just going to produce them for you. Surface metering is a big one. I mean, if everything goes well with TFDM and all the data comes in, is quality, and everybody's collaborating, you know, this is where, you know, the benefits really start to hit when metering kicks in and people are saving fuel and time out there in the movement area and whatnot. So, but this data, you know, as Carol talked about earlier, this will be, you know, the first new TMI that's actually being published in the last 15 years or so. So, and TTP is where you're going to go to get that information. Just a little bit about each service, you know, other than that, I mean, just whether, you know, when you go through it, most of these are event driven. So when something occurs in the system that forces a change to that flight data, or a new traffic restriction has been entered or modified or whatever, these go out, you know, pretty much immediately. And with the exception of the operational metrics, that's something that's computed, you know, on a periodic basis. And, you know, that's probably configurable, but I believe the default going in is 15 minutes. But even with the event-driven ones, if you just started up your system and you missed a bunch of updates or your system restarted, there's a periodic sync that occurs every 15 minutes, so you could get the full state of the information. There is no just, hey, I started now, give me everything, but you do at least have this capability to get the data every 15 minutes. So it's mostly good, but just be aware of that if you're a developer working with it, you know, working with sync data, you know, has a little nuances that you got to know that it's coming, and it's a full update. All this data, you know, and is again on our NSRR. There's the NASA TTP stuff, which kind of tells you more details, not just about the services, but also just some of the differences between what's in ATD-2's implementation and what TFDM specification has. So anywhere we don't actually implement something, we note that, so you know if you're working with the feed, you know what to expect. So along the lines of the sync, why I bring it up, I mean, headers are just generally important. If you work with any swim feeds, just know headers are important. Like you know, the content is what you really want to get to, but there's useful information about how to filter data, route data around, whether it is a sync, a heartbeat. You know, you might want to know that, and that's where you're going to find that information as opposed to in the data itself. So for any people that are dealing with actually consuming the data for you, an organization might be in the room, just make sure you know what's in the headers and you know how to work with them, and you might want to capture them if you're for analysis purposes as well. So probably really hard to see from the back, but you know, it's just, these are basically all the headers that are available in TTP. I'm calling it out just because I'm going to talk about the privacy levels in a second, but you can do everything from, you know, the timestamp of the message to what TFDM version is running to which aerodrome, which airport it's for. All that stuff, you know, you can find in the headers. And what I'm going to key on next is the privacy level. This one is kind of new to us on ATD-2, and we just recently, so if we have any TTP consumers in the room, this is actually changing a little bit as of this month as we implement the full privacy levels. We previously just did sensitive and non-sensitive, so you know, no sensitive flights have ever gone out to anybody that is not allowed to get sensitive data, but now we got the CDM and the CDM omit. So basically there's three classes of users. And this is pretty much true of most, you know, like TFMS as well. You know, you got NAS systems, which is basically they can get everything. You got CDM participants, which, you know, for the most part, other than sensitive data, they can get, you know, all the data elements. And now we have these other NAS systems, which you're not an FAA system and you're not a CDM participant. So there are certain elements like the EOBT, which are not meant to be shared with non-CDM members. So those are in the TTP feed, and now with these privacy levels, you know, those go out to the CDM folks, and if you're not CDM, you'll get a privacy level of CDM omit, which means that you got the message, but the CDM data has been omitted from that message. So you'll know that in the header that something's been omitted, and so if you're CDM, you know, you can go on, be happy you're getting everything. If you're not, you can go beat somebody else's door down and say, hey, I wish I could have this data. So you know, it is what it is. I mean, some of the data maybe is a little dated on whether or not it should be shared or not, and maybe that's a discussion for a future time. But the EOBTs are new, and there's probably good reason to hide those. But some of the others that come along with that, you know, pretty much anything the airlines are sending in falls into the CDM category, and so. All right. So then you get to the flight data itself. So, you know, you don't happen to know off the top of your head the number of elements, but I mean, there's probably a good 50 or 60 flight data elements alone.
At least.
And so I'm just calling out some of the ones that we tend to work with the most. And towards the back half of this, we've got some examples of some things that we've done with the surface type data.
So as we present this chart, as you look at the flight data fields here that Sean is presenting, there's a question that's come up several times here. Will TBFM metering times be available through this TTP feed? You can see the kind of the Apreq release times put on there, denoted. That's probably the more direct answer. There's also indirect references too as you go through and start to see some of the data fields that are presented. On arrivals and departures, there's certain surface times that are also influenced by TBFM. So if we have arrival metering that's going on in the airspace to that actual airport, the actual estimated landing times will take into consideration some of the influence of that. If there's cases of departure metering going on in the airspace surrounding that airport, we'll actually see the influence on will cause the Apreqs to influence some of our takeoff times.
So just to call it the Apreq in particular, the release time, and this is probably the best example I can give anybody for why you should get on the TTP and start trying to get educated and figure out what's in there. This actually, and Tim, I hope you don't mind me calling you out, but I mean, Tim asked me this question the very first time I ever talked about TTP, and Apreq release times were not in TTP at the time. And, you know, we went back to the FAA and the TFDM team. We said, hey, this one is coming up a lot, and it seems like they would really like it in there. And they made the adjustments. Said, we'll put it in. You know, rather than having to go get it out of TBFM, it makes sense to put it in there, and they added it in. So, you know, I'm not making any promises that you guys can get anything else in quickly. I'm just saying, like, it's better to find out now if you feel like something really should be there. So, you know, just kind of moving down the list. I mean, again, I mentioned runways earlier. You know, this is another piece of information that you can sort of get like runway from like TBFM, but you don't know exactly what flow you're in. I mean, with TFDM, you're getting the predicted runway. What runway do they think that flight's going to take off on? You can get you'll get the actuals as well. You get transit times. You know, how much time you've been out there waiting in a queue. You know, so between the combination of the predictions and the actuals, I mean, it's going to be pretty nice. I mean, again, I've been in the surface world for a long time, and I mean, the amount of effort I could have saved if I'd had this data, you know, all along would be pretty awesome. So kind of continuing on, you kind of shift from the flight stuff into other areas, you know, the traffic management restrictions, you're getting miles and trails, minutes and trails, the Apreq programs that are out there, airport departure stops, you know, and then on over to the airport information side, you got the configurations and runway closures, arrival rates, departure rates, you know, all the stuff when it's available is being published when it's entered. If you've tried to get any of this information out of the existing sources now, you know, I mean, NTML is not publicly available. It kind of moves its way in some regards to the OAS, which we scrape that on ATD-2, works its way. Some of it gets in the TFM flow, but a lot of it depends on how it's actually entered. If you sat in on some of the TMI sessions, they'll tell you that it's not consistent throughout the NAS, and so not everything's making it in the TFM flow. There's some software issue with why the Apreqs aren't getting in there that'll probably be resolved in a future release. So again, I mean, there isn't a great source that's consistent to get this information now, and you know, TTP will be your consistent source of that in the future. All right, let's take a look, see what else we got for questions before moving some examples.
One of the questions that's come up has been pretty popular. Will the TTP flight data have overlap with TFM data studs and SFDPS? In general, no. We don't. The philosophy is to go through and not republish data that other feeds are providing that may be the more authoritative source. We will not go through and republish the detailed surface surveillance position. TFM data feeds that come in that have additional data in there that we wouldn't just republish if we didn't add any particular value to it. So in general, if TFDM isn't providing value or ATD-2 isn't providing additional value to some of the data that's coming in, the general philosophy is not to do that overlap, because the more overlap really just creates more confusion that we have to unravel later for any of the consumers.
So we're on questions. I'll just go ahead and knock out a few simple ones while we got the list up here. But one of the ones, I guess, a little confusion, NASA TTP, you know, is it the same as the FAA SWIM or NASA TTP, a research prototype? NASA TTP is a prototype implementation of the TFDM TTP specification. You get it on the SWIM R&D. It's just a research prototype using the operational data that we have on ATD-2, but it's not intended to live on past, you know, TFDM. When TFDM comes, the NASA ATD-2 TTP one goes away. So NASA TTP, ATD-2 TTP, it's interchangeable. So that maybe, hopefully that clears up any confusion on that one. Another question about, does TTP use FIXM? The answer is yes. I mean, the flight data is in FIXM format. The TMIs, the airport configurations, are their own XML specification, their own schema specifications, but the flight data itself is in FIXM format.
It's the initial TFDM publication, because we have 2 builds going out. First build that goes to Phoenix that we're at actually, and very shortly going to start publishing data in a limited test form, probably about a month from now, on a more ongoing basis starting next year. that's going to be a Fixum 4.0, I believe. And then the Build 2, which starts from Charlotte and beyond, our 7th site that has the surface metering capabilities, that will be Fixum 4.1, kind of a variant actually, a future 4.1x version. So we're kind of leaning in a little bit, working with the Fixum team to get as much compliance as possible.
All right, so back to some of the slides here. So we're going to move through some examples, and for the MITRE mobile app, the mobile application that was just presented, this is a little bit redundant to that if you sat through the last session, but you know, an example again is, you know, working with MITRE on the ATD-2 prototype. They have developed a prototype application, mobile app. It's actually kind of going through some evolutions where it was an app, then a text-based, and now it's looking more like it'll head more towards like a progressive web page. But anyway, they're able to send in EOBTs, and we ingest those, and we use that information. But we're publishing this information out, but we're not publishing directly to them. We're publishing out over SWIM on the R&D network, and they are a TTP consumer on that, just like anybody else could sign up and become. So they're using that information, and they're basically relaying certain pieces back to the GA pilots, like whether or not they're impacted by a TMI restriction, what runway they're going to use. These are the kind of things that they can give back to the users through the application, and they're getting the data, and there's no proprietary connection that we're sending data back to them. It's going through the SWIM feed itself, and they basically use that in a pretty clever way to get that information out to the mobile app users. All right, so in full disclosure, I'm going to go through a number of reports. These reports are basically based off of the information that you can find in TTP, and you could generate these reports themselves. But in full disclosure, we didn't actually use the TTP data since, I mean, we are the surface system producing it in this case. We have other databases that have the data, so these are a lot of real reports that were generated, but basically I asked some of our analysts, hey, go through and some of the reports that we generate and look at some of the ones that you could truly generate using TTP data, and without actually having to have any of the back end of the system. Like the data should be there to be able to produce these kind of charts and graphs and whatnot. So these are just examples. It's real data, reasonably accurate that we're putting in here. I mean, it's just it's not made up. Just letting you know, I didn't actually set up a TTP consumer and generate these off of that. An airport configuration report. I mean, you just want to know what time a configuration was going to start and end, what configuration you're in. Pretty simple example, but, seems simple, but not something you can easily get today. And, so that's first simple case, something you could pull out of TTP. So then you get into average surface counts. You got number of flights, that during different buckets, whether it's, using the block times, their actual movement, when their actual takeoff time, landing time. So you have all these, and you could basically, come up with counts of, during different bins, different time frames for these sorts of things. So all that data, all your actuals from, out to off, they're in the TTP feed. So the Apreqs, should be a favorite of most. I mean, I think, if anything, there's a lot of reasons to go to TTP, but I have a feeling a lot of people go just to get the release times, when it's full up, because it's pretty easy to get it compared to other sources. But, you want to know which flights have been Apreqed, to which destinations. You could pull that data from there, and you could basically work these charts and sort it out in these various ways if you're just trying to know who had release times assigned to them. Things like average taxi times. I mean, you could, come up with your own metrics to kind of compute this kind of stuff, but they're pretty much giving you the exact taxi times in the feed. You could even derive it from other actuals, in this case, the transit times, but there's also just fields being pumped out that just give you the calculation already pre-done for you. So these are in the feed, both for arrivals, departures, movement area, non-movement area. Same thing, so reversing it for the arrivals. So the only thing about this chart that you wouldn't necessarily have out of TTP itself is, the actual adaptation of the airport itself. So if you want to know what gates were even available to begin with, that isn't necessarily in the feed. But if you know what gates are at there, you could basically roll it up and create something like this. So, this particular one is showing which gates were occupied and unoccupied. So we kind of have this master list, of gates, and kind of looking at who's using the A gates and then the B through D and the E gates, and you're kind of looking at the occupancy using times out of the TTP feed to kind of figure out who was using what at what time. So again, information, just even having the gate, it's called a stand in TTP, but that's information that you basically would have to typically go to a third-party service to get that data right now. It's not actually in one of the swim feeds. So this would probably be a pretty big one in a lot of circles, runway accuracy. Every prediction, you kind of back it down. I mean, how accurate your predictions are, you need to know what configuration you need to know what runways are even active. So you could model a whole lot of things, and you could, historically you might come up with some pretty good average numbers, but if you're really trying to get into good predictions, you got to have good runway accuracy. And basically, TFDM, you're not going to get any more accurate than being told what runway this flight's actually going to be using. So so we have this split out, and then we're able to kind of look at the difference between what was predicted at out versus what really happened to see, who actually hit the prediction. Did something change? Is it just some anomalies? A lot of this for us is like, if you see too many of these, something's off. So you go digging into the data to figure out what was really going on. But this data is being pumped out, and all things that you could build, a tool that showed the same kind of things, and whatever kind of visualization capability or tools that you have that you want to incorporate it into. Similar in the spot, so spots vary, and where they really are going to cross is a lot more volatile than knowing exactly what runway, and different airports operate the spots differently. So predicting spots is a lot different for us, but so the accuracy you see is a little bit lower than you would see for runways, which are pretty. You can write rules pretty a lot better, and you know from the inputs from the controllers where the spots are a little bit different, but you're going to have that data. So I mean, the improvements can be made just by doing the analysis on the data itself and giving the feedback, and kind of going. And that's usually what we're doing. I mean, we're using it as a kind of a feedback loop to kind of keep improving all these things. All right, so there's a number of examples. So if you have any questions about what you could do with the data, if you have any in there, we can take a moment, pause for those.
So we'll do a couple questions. The one question that's been there for a little bit here. Will TFMS and TBFM consume from the TTP swim feed? TFMS is for sure. They're consuming data. They're actually making application to kind of view the data both at the TRACON and center and command center level within the FAA. But they're also using that to help with some of their processing and perhaps with additional modeling that they do. TBFM, they do a limited amount of consumption. We consume probably more of their data than they do of ours, but there's some discussion about potential additional consumption that they could do over the time.
So a couple other questions a little bit lower down. Is the airport and runway in use information available only for participating airports? And yes, that would be true, and only the airports that have actually been put into IOC. So there's a waterfall model that's published out there for TFDM to let you know what sites are coming online and when, and so that information, even though TTP will be active, that information will only be available for the TFDM airports that are actually online. But I mean, they're going to have a pretty extensive list. I mean, all the major airports and a lot of lesser equipped airports will be part of the TTP feed.
So there's one question here, and maybe another one here. It's related. What is the total coverage of airports intended for TFDM TTP data? That's similar to the last question. What is the time frame for adoption? The total coverage is 89 airports. There's a published list, I believe, if people are interested to understand those 89 airports. In general, it does cover the large, busiest airports. It also goes through a bunch of criteria that was selected that Mike probably alluded to help with both value to the FAA and value to the industry as far as those coverage of those airports. But it is not every airport. It is just those 89 at this point in time. Will the eventual TFMS TTP, I think that meant TFDM, TTP feed have a distributed architecture like Studs, which has 38 separate producers basically? Yes, every TFDM airport is going to be its own producer, and that's why you can subscribe to it down to the airport level. In addition to essentially the properties, elements that Sean put in there earlier, we do have some additional change in there to allow filtering even down to arrivals from departures if you want to go through and just subscribe to just departure data or arrival data. And that was based on some feedback from some internal consumers inside the FAA use of TTP data.
And kind of along those lines, another one about the Apreqs, are they limited to departure and arrivals in participating airports or nationwide? That they again would be limited to TFDM airports. You know, you're only going to get flight data from a flight arriving or departing a TFDM airport for that particular one. So that would also apply to the data elements as well.
And just to kind of round out the question that's getting a couple votes, will this data feed be supported with multiple nines of availability? If airports and airlines are being asked to utilize this data and make operational changes based on it, it needs to be highly available and supported. So the TFDM system itself has at least 4 nines of availability. It's rated efficiency critical inside the NAS. That would cover us as a producer. However, there is a SWIM infrastructure in between. It has a variety of different demands and usages on there. I think the overall availability is actually three nines, or actually 2 nines, 99.9% available. But I know there's a lot of infrastructure improvements that have gone in over time, so I think that it's not, it's hard to go through and look at that and see if that's really the stated availability. So.
Josh, want to add anything there?
Yep. Yep. So Josh was basically saying that if SWIM services in between are also rated as efficiency critical, which would take you up to about 4 nines of availability.
All right. So back to the slides. So you've heard enough. You're interested and you want to get moving. So right now, the best way to deal with this is, again, it's SWIM R&D is what we're talking about for the NASA ATD-2 TTP prototype implementation of it. So most people, if you connected to SWIM, you have a SWIM rep, and you probably had to get connected to SWIM R&D as your first step. So if you are not connected to SWIM R&D already, then you need to go establish a connection, which is going back to your SWIM rep and making that known. And the process could take a little bit longer if you haven't had it, because you got to go through the FDI connection testing and all that. But if you already have that connection to SWIM R&D, it's just a matter of making that request for the queue. Once the request is made, basically NASA gets notified, and we basically turn on the additional data for that. It'll be handled a little different when TFDM comes along, where SWIM will handle all the routing rules. They're just going to publish it once. We actually thought our number of consumers would be 4 when we set out initially, and you know, it's growing. So, but it's like any other SWIM feed once you get going. So you make your request, you'll get assigned a new queue, you start consuming the data, and that's pretty much how it works. You know, if you already connect to SWIM R&D, you're probably talking less than a month, you know, to actually go from time of your initial request to actually having, you know, data coming in. If you don't have SWIM R&D connection, you know, I don't know, I would probably factor in another month or 2 to get through the FDI testing. So, you don't have to have a CDMO. You do need to have it if you're going to get CDM data. So you only get CDM omit if you don't. So you will not get the CDM data, but you will get data. Okay. So I've alluded to the resources a number of times, but I mean, these links are in the presentation, both from TFDM information to their implementation schedule is out there. If you're not familiar with the on-ramping process and need some guidance on that, there's some links out there in the FAA to help you navigate those waters. If you don't have an NSRR account, it's probably worth getting. They're free, but access to various, all kinds of different programs that you can get data out of there. But that's where we're maintaining our TTP documentation. There's also the NASA website, which you can go to kind of get some of the background on what we've done here. So all worth reviewing if you haven't seen them. But these links will be posted out, so you have a link of links. So in the NSRR documentation itself, we have the JMS DDs and our message descriptions. There's a document that kind of says, here's the specifications, here's what we worked off of, and then there's basically appendix sections in all of them that kind of list out, okay, here's what was put out in the specifications, and here's what we implemented, and you can kind of correlate all those. So, I mean, we hit all the major ones, so I think, you'd be plenty satisfied with what's going in there, but, there are some elements that we couldn't implement, so they're noted, in those cases, and you can find all that information up there. The schemas, so as Eric alluded, there's a little bit of a kind of working with the FIXM team to get the FIXM schema, as desired for TFDM. And in one particular case that working with the TFDM team, we actually modified the FIXM schemas to deal with the concept of a nillable field. So, if you're used to working with XML, if you have a data element and then that data element is being nulled out, wiped out, it doesn't, it's no longer valid. In XML, if you can't nil it, it just looks like it's gone. It just doesn't appear in the data. Well, it doesn't appear in the data doesn't mean it was wiped out. So this concept of nillable is an XML term that you can nil, and so that's how it's being dealt with. But that wasn't supported for a lot of the elements that we needed to be able to remove that from. So working with them, that's what we came up with, and so that version of the schema is also published out there just to make sure that everyone understands that really is the only difference from what you would have found by just downloading the FIXM 4.0 at the time. But you get the schemas, some sample data is published up there, and so it's all out there to start poking around with.
So I have a couple of questions, and I'll give you a little bit more TFDM, TTP data. One question that came up was currently some data such as EOBTs is provided to the FAA via the TFM data request reply. Will that exchange move to the TFDM TTP? No. TTP is only going to be a publish subscribe behavior type of interface. So we will continue to publish data out. TTP from a FAA domain, as I said, we are currently installed at Phoenix. The TFDM system is there. I was there a month ago watching the system run in shadow mode, consuming data from TFMS, TBFM, FDIO, which is essentially ERAM data, ASDX data, surface surveillance data, essentially, and STARS data, fusing that all together and going through and getting ready for actual publication. We will go through some test activities. During those test activities, we will briefly be publishing data out onto the FAA SWIM infrastructure. From there, over the next 5-6 months as we ramp up, eventually Phoenix will be publishing data. The Phoenix data that we publish is a build one system. It's not the full capability system. Our system is implemented in 2 major phases. Not to be confused with configuration A and B sites, but the first capability is predominantly electronic flight strips with some limited surface management capabilities. The second build, which is key siting at Charlotte to subsume essentially the capabilities that ATD-2 put out, is going to go through and put forth the full surface scheduling, surface metering capabilities. When we publish data in build 1, we will have most of the business functions that Sean talked to, with the exception of the surface metering business function in TTP, since we're not really having anything to fulfill that. In addition, the other business functions, there are elements in there that aren't fully satisfied because the functional behavior behind them is not there until build 2. So you'll see a version come out. That is another opportunity in the interim, essentially year and a half between when build 1 is out operational, when build 2 starts to show up, to go through and do some integration through the SWIM infrastructure. We are also looking at ways to go through and look at how we allow collaboration. What we haven't talked about in this discussion is the TFCS, the TFDM Flight Operator Collaboration Service. That allows us to do the exchanges, as was alluded to in some of the other discussions in other areas, to allow airlines, essentially folks who have CDM participant level access, to supply data, to do request reply, to do flight substitutions, to provide us with non-movement area ramp closures, and provide some of the data that we're not getting through the TFM data feed. This will allow that full data exchange. This is not done under ATD-2 because a lot of the ramp tools are being provided as part of the demonstration in the actual research prototype. That's some of the differential that Sean was alluding to. So to compensate for that, we will have this SWIM service that will need to be done to support the full build 2 capability. As part of that, we are looking at ways to provide an integration test bed to allow the CDM participants that would normally have access to that service to practice with us before we actually show up at a facility, build 2 operationally like Charlotte, and try to go through and replicate that. There are, of course, a number of other non-technical solutions and logistics that need to be worked through, as far as just because we put a TFDM system at Charlotte, as an engineer, doesn't mean it automatically just goes up that next day and supports where NASA left off. There's still a lot of coordination with the participants at that airport to go through and make sure everyone is ready to supply the right data and migrate over to a surface metering concept at that airport. But we're looking at ways to go through and provide an integration platform to help with that transition. A couple quick other ones. Is TFDM TTP future state only going to be available for Config A TFDM airports? The quick answer is no. They'll be available at all airports, all 89. So not just the subset of those, not just the Config A airports, but at those airports that do not have the full Config A capabilities, the TTP data feeds would be limited in what you could actually get. For instance, the surface metering data feed would not really be provided or empty, essentially, for a Config B site.
Yeah, I think Eric kind of hit all of them that I wanted to touch on. But these questions come up a lot, and I just want to reiterate that TTP is not the same as the request reply that you're sending in EOBTs. It's a process to go through request reply and get through the testing to be able to submit things to TFMS and make sure it's getting in properly and being validated. And I think some that have been through that process, it probably is quite painful, but it's part of the process of having good quality secure data being transmitted in. TTP is just being published out. You subscribe to it, so I think there's a little trepidation of like, we just went through all this trouble to get EOBTs in. Is TTP going to be? I mean, it's consuming is a much simpler animal than getting into the request reply. The other services that Eric is alluding to, the TCFS, did I get that right?
TFCS.
TFCS, sorry. That's got some substitution capabilities, so that's going to be a little more involved to get that tested out and work with that one. But but as it should be. It's a complicated you know, to get the full benefit out of metering and substitutions. I mean, it needs to go through a little more rigorous testing. So I think we kind of touched on most of the questions. So if anybody has more questions, you got a few more minutes to pop them in. I mean, if you see a question in there you feel like we haven't answered, you know, go ahead and, you know, upvote it. And
Or you can just do it the old-fashioned way and yell it out.
that's kind of craziness. We don't do that. That's a good question. I did miss that one. So there is a list, but I don't know if it's published anywhere. So I got the PowerPoint from the TFDM team so that I knew. I don't know that it's actually published out there. So
I don't think it is.
We'll take an action. Yeah, we'll take an action item to figure out the best way to get that information out. So if you're a CDM member, you can get the list that's being protected. But if there's another unfortunate aspect of it at the moment that, you know, I think we're trying to see if we can get a little more clarity on it. But, you know, it's CDM elements are kind of, you know, just saying EOBTs, and, you know, if they send in, you know, a parking gate or something like that, you could say, okay, but there's a couple of them that you could get a data element from an airline, but it also could be produced by the TFDM system. And if the source isn't tracked in TFDM, you know, just if there are other CDM elements, you might actually get something filtered out that maybe, you know, actually wasn't a CDM element. So there's still a little bit of kind of, I think, work to get it all fully settled in before things truly go operational. But we'll try to get the information out. You know, I have a pretty good PowerPoint, so if we could take some excerpts out of that and get that shared out somehow, that's probably.
Yeah, I thought I might have the quick answer for you, but we'll get that.
Just throw your hand up or shout it out if you got anything else. Still got a couple minutes.
What is the actual reason to omit the CDM? In Europe, we did the other way around. Broadcast everything that we can broadcast because the information gives you.
I mean, in my understanding is just it's going all the way back to, you know, the whole concept of CDM, the collaborative decision making, and just kind of the MOAs and the standards that were developed under there are still kind of carrying forward now. I do think, you know, it's a good question to ask, like, you know, should it cover any or all elements, you know, nowadays? And but, you know, it's definitely above me to a lot of people in this room, you know.
I don't think you're going to find that the list is very extensive as far as the amount of elements it's covering up. So it's more open than it is protective.
All right, so we probably got time for one or two more. If all right, well, Eric, do you want to close out with anything else?
Thank you for your time.